been covering Jackson today, and he's talking about qualia. So before I go into his actual arguments, I'm going to talk a little bit about primary and secondary qualities. So these are technical terms in philosophy. Primary quality is an objective quality. It's out there in the world. So some examples are mass, shape, charge, density, material composition. And what I mean by out there in the world, I mean that they are not mind dependent. So the weight of this energy drink, this can of liquid, is a fact about that object. It has nothing to do with what I think about or my mind. It's anybody who picks up this can will feel the same weight. Anybody who puts this can on the scale, whether it's here or I don't know, in Chapel Hill, they're gonna the can will weigh the same. So its weight is in the world, it's not in my mind. To contrast this primary quality with secondary qualities, those are subjective qualities. They're in our mind. So pain, intentionality, what we talked about last week, but also color. So both are equally real. They're both real phenomenon in the world, but one is objective, which means that anybody looking at this can determine the mass, figure out what the mass is. And if I figured it out and you figured it out, we both come up with the same answer. And we can create a scientific explanation for that mass. But color isn't like this. So when you look at this color, and it's like an aqua blue color, it might be slightly different than when I look at the color and I see this aqua blue. The color is in our heads. It's not in this can. It's not out there in the world. It is entirely in our heads. So just like intentionality, these secondary qualities are a problem for the physicalists. So if we assume that the mind is just like the brain, they're one and the same thing, then we need an account of how the brain produces these secondary qualities, this color, or I feel it, it's cold, like that sensation, that cold sensation. So one of the objectives of neuroscience is to show the physical reality, how it is that the brain produces these secondary subjective qualities. So how is it that this cluster of neurons firing in my brain gives off this subjective quality of a light aqua blue? Part of the goal of science, part of the goal of neuroscience is to figure out some objective scientific explanation how physical matter in our brain could have the property of qualitative aspects of experience that we mistakenly spread out in the world. So a lot of people are going to say the color, like this can is this color, and that's not true. It's just it's a fact about color and about that experience that it's not a fundamental part of the can. It's us humans looking at it and ascribing that color to it because the color is in our minds. Now, it might be a little bit confusing to think, well, okay, well, yeah, maybe you see it a little bit different than I see it, but it's still the same color. But think about how like other animals look at the world. So when my dog sees this can, she doesn't see the exact same color that I see because her physiological makeup doesn't allow her to see that color. But she could still feel the weight of this can in the same way that I feel the weight of this can. These objective qualities apply to other creatures as well. So I know that like dogs aren't doing science, so they can't determine the mass of the can, but they can still like pushing a rock, right? So I can push a heavy rock and my dog can push a heavy rock, and its heaviness is the same for both of us. But when I look at the rock, I might see a slightly off gray color and my dog might see an entirely different color. And if we think about even other animals, which we're going to talk about a little bit next week, they're going to have entirely different secondary experiences, but the primary experiences, the primary characteristics, those are going to be the same. And so again, for the physicalists, for most, I don't know if neuroscientists what the makeup is, like how many are dualists, how many are physicalists, but I'm assuming that most neuroscientists are physicalists. And I say this because way back in the beginning of the semester, we talked about how if you're a neuroscientist and you're a dualist, then there's something incompatible about the goals of your discipline and your fundamental metaphysics. Because science operates under the assumption that you can measure and find data about the things in the world. If you're a dualist, you can't measure or find data about something that's immaterial, and that's soul, the mind. So if you're a neuroscientist, then I'm assuming you're a physicalist. And if you're a physicalist, then you need to find some objective explanation for our color perception. And why do you need to do that? Because our color sensation should be a part of our brain, our physical makeup of our brain under the physicalist picture of the world. And this isn't only just for color too. It's pain is another big one that the neuroscientists should be worried about. So Jackson walks us through two different thought experiments. So the first is Fred, and I'm just going to read it to you. People vary considerably in their ability to discriminate colors. Suppose that in an experiment to catalog this variation, Fred is discovered. Fred has better color vision than anyone else on record. He makes every discrimination that anyone has ever made, and moreover, he makes one that we cannot even begin to make. Show him a batch of ripe tomatoes, and he sorts them into two roughly equal groups, and does so with complete consistency. That is, if you blindfolded him, shuffled the tomatoes up, and then removed the blindfold and asked him to sort them out again, he sorts them into exactly the same two groups. We ask Fred how he does this. He explains that all ripe tomatoes do not look the same color to him, and in fact, that this is true of a great many objects that we classify together as red. He sees two colors where we see one, and he has in consequence developed for his own use two words, red 1 and red 2, to mark the difference. Perhaps he tells us that he has often tried to teach the difference between red 1 and red 2 to his friends, but has gone nowhere and has concluded that the rest of the world is red 1, red 2 colorblind. Or perhaps he has partial success with his children. It does not matter. In any case, he explains to us that it would be quite wrong to think that because red appears in both red 1 and red 2, that the two colors are shades of the one color. He only uses the common term red to fit more easily into our restricted uses. To him, red 1 and red 2 are as different from each other as all the other colors as yellow is from blue. This guy Fred, when we show him a tomato, when we show him a stop sign, he sees something different than what we see. And it's not a matter of seeing just a slightly different shade of red. To him, it's like an entirely new color. It's as distinct as like this white is from this blue. And yes, I drink a lot of energy drinks. But when we see these two objects, this is an entirely different color than this. It's not like this green and this green is like two different shades of green. That's not what it's like. What it's like is like two entirely different colors. And he has proven scientifically that he can sort these colors. Or what does that tell us about the mind and the body? Before I delve into that, I want to talk a little bit more about another possible thought experiment related to Fred. We're supposed to imagine that after Fred dies, we study his brain and we learn from the way that his brain works and from the physiological makeup of his brain how to develop these eye drops. And anybody who uses the eye drops can now see red 1 and red 2. So here's the main part of the thought experiment. When you put the eye drops in your eyes and you look at a batch of apples, do you learn something new? Do you now learn a new color? Do you gain new knowledge from this experience? That's the big question. Before I go into the implications of this, let me just go over Mary. So Mary's the second thought experiment, and this is the much more famous thought experiment. This is the one that anybody who's taken an intro philosophy class usually learns. Like this one, Chinese room, Descartes' dream hypothesis or thought experiment. These are all the big famous thought experiments in philosophy. So this is Mary. And again, let me just read it to you. Mary is a brilliant scientist who is, for whatever reason, forced to investigate the world from a black and white room via a black and white television monitor. She specializes in the neurophysiology of vision and acquires, let us suppose, all the physical information there is to obtain about what goes on when we see ripe tomatoes or the sky, or use terms like red, blue, and so on. She discovers, for example, just which wavelength combination from the sky stimulates the retina, and exactly how this produces via the central nervous system the contraction of the vocal cords and expulsion of air from the lungs that results in the uttering of the sentence, "The sky is blue." What will happen when Mary is released from her black and white room or is given a color television monitor? Will she learn anything or not? So that's the big question. Do we learn something new when we have this new experience? Mary, we're supposed to imagine that she's in this black and white room, and maybe we even give her some like glasses so that she sees her own skin as just black and white. If she cuts herself, all she sees is black and white. Like, she has never ever seen any color for the entirety of her life. And I know that's crazy to believe, and obviously like IRB is not going to approve that study, so it's never going to happen. We're just supposed to imagine that this person has never ever seen color before. So when she finally leaves the room and she has her first experience of color, does she gain new knowledge? And if you think that she does gain new knowledge, then you're one step closer into buying Jackson's argument. And his argument is going to end up with the conclusion that physicalism is false. So if you're a physicalist and you think that Mary learns something new when she leaves the room, then you're in trouble. So this is called the knowledge argument, Jackson's. And again, it's an inference from epistemology to metaphysics. So how does it work? It says X knows that P. So X knows it's an epistemic fact, a fact about X, what X actually knows. Therefore, P is true. And that's a fact about the world, that the world is arranged so that P is true. And we went over this. This should be familiar with dualism, with Descartes and with Swinburne. So we have these epistemic premises to a metaphysical conclusion. And how does that work? The reason it works, and I don't know if you guys recall, but when I was talking about it in relation to dualism, I said that the epistemic premises need to be grounded by some metaphysical premise, some metaphysical fact about the world. And in the case of Descartes and Swinburne, they're using Leibniz's law, which is it's a fact about logic, and logic is something that's in the world, a fact of reality. And so from that, they were able to derive a metaphysical conclusion from their epistemic premises. This argument works in a similar way, but Jackson is not using Leibniz's law. Jackson is using the definition of knowledge. And it's this definition of knowledge that grounds his epistemic premises and allows him to draw a metaphysical conclusion. I'm not sure if I went over the definition of knowledge in this class yet, but I will right now. Here, the definition of knowledge that I'm going to be using is a justified true belief. So there are three conditions. Together, they are necessary and sufficient for knowledge. So if you have a justified true belief, then you have knowledge. Notice too that this is a real definition of knowledge. This is not like our intuitive, what we believe, like common sense conception of knowledge. Like, no, this is supposed to be the necessary and sufficient conditions for knowledge. So that this definition is supposed to cover all cases of knowledge. It's a highly philosophically robust definition. Definitions like this that are necessary and sufficient fall into the category of metaphysics because they are statements about truths in the world. So if this is really the definition for knowledge, then this is what knowledge is in the world. So even though we're talking about knowledge, so you think it's an issue in epistemology, it's also an issue in metaphysics, because the challenge of finding definitions, or the discipline of finding definitions, that good definitions, philosophical definitions that actually cover every single case of the thing we're defining, are going to fall into metaphysics. So if this definition is what grounds Jackson's argument, then it works because it's a metaphysical principle. What is knowledge? Like, what is the reality of knowledge? It is justified true belief. But there is this intersection between epistemology and metaphysics here. In terms of the actual definition, I would say that's a metaphysical principle. So Jackson's argument primarily focuses on, or relies on, this second condition of knowledge, which is truth. So knowledge requires that the proposition you know is actually a true proposition. So if you have knowledge of P, then P must be true. You cannot know a falsehood. Now, this is a little bit confusing for students because you can know that something is false, So if I sit here and I say, I know today is Friday, I don't know that. Why don't I know that? Because it's not actually Friday. Today is Friday. That proposition is false. Now I can say that I know that it's false that it's Friday. So I do know that because I'm justified in knowing that. I'm looking at a calendar right now and it's not saying Friday. It's true that it's not Friday. And I have this belief that it's not Friday. So I know that it's false. But if I were to sit here and say, I know that it's Friday, or if I know that Obama's the president right now. See, I can't know that because it's false. So that's what I mean here when I say that if you have knowledge of some proposition P, then P must be true. So to ground Jackson's argument, he needs something like this. X knows that P, if X knows P, then P is justified, P is true, and X believes P. Therefore, P is justified, P is true, and X believes P. That's just the modus ponens right there. And then to get the final conclusion, so P is true. That's not an argumentative form that we've covered in class, but if you have a conjunction of two or more things, necessarily a conjunction, every single conjunct is true. So if a conjunction is true, every single conjunct is true. So if every single conjunct is true, from knowing that a conjunction is true, we can just pull one conjunct and say that's true too. And it's an inference from our definition of the word and, the way that and works. And if that's interesting, then take some logic, because that's something that you would cover in logic, how you can make that kind of inference. But of course, philosophers know what knowledge is, and they know that it's justified true belief. And so Jackson doesn't need to spell this out for us, the audience, because his audience is primarily philosophers. But it's important to note that this is how he's able to get from those epistemic premises to this metaphysical conclusion. Which, here's the argument. If physicalism is true, then we, or science, can know everything about the brain. Mary knows something that the neuroscientist who knows everything about the brain doesn't know. And here, when I say the neuroscientist, I just mean Mary before she left the room, because that's the setup of the thought experiment, is that she's this amazing neuroscientist who's focused primarily on the neuroscience of vision. What do we get? This conclusion. So there's some proposition P about the world that is true that the neuroscientist does not know. And then we can infer that physicalism is false. And why can we infer that physicalism is false? Is because these premises are showing that this, from premise one, the consequent is false. So it's a modus tollens going on. We have this scientist who knows every single thing about the physiological makeup or the physiological process of vision, but yet she learns something new. She has new knowledge when she leaves the room. Therefore, science cannot know everything about the brain. So with science, she thought she knew every single thing about the brain, but yet when she left the room, she learned something new. She learns what it's like to see red, what it's like to see blue, what it's like to see color. Assume we know everything there is to know about the brain. If the mind is the brain, then we would also know everything there is about the mind when we learn everything there is about the brain. But yet this thought experiment is supposed to show us that there is some fact about the mind that we cannot know even when we know everything about the brain. What's that fact? What it's like to see red. Therefore, physicalism is false. And let me just read a little bit more from Jackson to bring this point home. So this is on page 357. So what will happen when Mary's released from her black and white room or is given a colored television monitor? Will she learn anything or not? It just seems obvious that she will learn something about the world and our visual experience of it. But then it is inescapable that her previous knowledge was incomplete. But she had all the physical information. Ergo, there is more to have than that. Therefore, physicalism is false. So knowledge of all the physical processes wasn't enough to get knowledge about the entire mind brain. Therefore, there's something about the mind out there that you cannot capture when you learn everything about the physical brain. So this argument depends on buying into that thought experiment. It's this intuitive pump. So Jackson says, obviously she learned something new, but that might not be the conclusion you arrive to after reading this thought experiment. But a really powerful thought experiment allows you infer from the inconceivability of something in the thought experiment to the necessity of the truth of the conclusion. And in this case, it's about the nature of thought. If you believe that Mary learned something new, then Jackson's argument seems to be the implication of that belief, that the belief that she learned something new. And if you don't like that implication, then you have to really figure out a way to get out of the argument while maintaining the belief that she learned something new and she leaves the room. And that's the struggle here, is you can't just dismiss the thought experiment. You have to accept the thought experiment, but then find a way to make that thought experiment compatible with your disagreement of the general conclusion of his general argument. So there does seem to be one problem with the view, and I think a lot of students try to catch on this, but I'm gonna try to talk you out of it. Because again, a lot of you guys you're immersed in that scientific worldview. You believe in science, and so it's difficult for you to accept this thought experiment. You might want to say, like, no, this thought experiment's stupid. Not only would it never happen, but even if it did happen, it wouldn't happen the way that Jackson says it would. Here I have written on the slide, if there's a difference in effects between her subjective experience and our subjective experience, then she would learn about what it is like to see red from within the room. So let's think about Mary again. So she knows everything there is to know about the physical process of seeing red and about the physical process of red color experiences, because she's a scientist. So she's done a bunch of experiments in this room to figure this out. Just for her, on her screen, it's just like a shade of gray. It's not an actual red color, but she gets data from people outside of the room who are seeing the real color red and not just a shade of gray. So presumably she has all this information about how normal people see the color red. But until she leaves the room, she has never herself had a red color experience. So she does not know what it's like to have that red experience. She also does not know that she is missing that experience. There's no way to communicate to her that there's something that she's not getting in the room. Because how could you tell her that there is such a thing as having a qualitative experience of redness when she's never had it and she's not going to have it in the room? So could you just show her a stop sign and say, the kind of sensory experience that everybody else has when they look at these things is missing? Like, would that work? No, it wouldn't work. Under Jackson's story, under the story that he tells, this wouldn't work. When you show her the stop sign, she's just going to see a shade of gray, but she's going to assume that that's what everybody else is seeing when they see the stop sign. And so the only way to tell her that there's a difference between what she sees and what everybody else sees is if there was this difference in effect between her subjective experience and our subjective experience. That would convince her that there's a difference between her experience and our experience. We can tell that it's different because your experience has some physical effect that we can measure and detect, and our experience has some different physical effect that we can measure and detect. Because the physical effects are different, there must be some difference in the initial experience. There's no other way to tell her that the subjective experience is different. The only way is to measure the physical effects of the subjective experience. Mary knows everything about the brain, and if there is some difference between her subjective experience when she sees the stop sign and our subjective experience when we see the stop sign, she's going to know the difference. And that's just written, that's the way that Jackson wrote the thought experiments, that she is the most brilliant genius scientist ever. And so she's measuring the physical effects of each experience. And so if there is some difference there, she would know it, because Jackson says she knows everything about the brain. So if she knows that there is some difference, even before she comes out the room from her experiments, then she would know that there is some experience that she's missing. There's some qualitative aspect of that experience that everybody else has But, and she would know that she's missing that because of the physical effects of those experiences. But that's ruled out in the story. So Jackson says she knows everything, and yet she learns something new when she walks out. So that would mean what Jackson is implying is that there is no physical difference between us seeing the stop sign and her seeing the stop sign, despite the fact that when we see the stop sign, we see red, and when she sees the stop sign, she sees gray. And again, that's just part of the thought experiment, and you have to agree with the thought experiment insofar as you have to accept, all right, these are the conditions that Jackson is forcing us to conceive and think about. And then from that thought experiment, what can we say about the world? And the story is only going to work for Jackson if that subjective experience of seeing the redness has no physical effect whatsoever. And that's what I'm saying about you guys maybe being immersed in the scientific worldview, is I think that people who don't buy this argument, who aren't taking this argument seriously, just can't accept the thought experiment that you guys want to say that, so when we see the stop sign, my brain's going to produce some physical effect. Some cluster of neurons is going to fire over here rather than this cluster of neurons over here. And a lot of students want to say when Mary sees the stop sign, some cluster of neurons over here is firing. So it's not the same cluster of neurons. And since it's not the same cluster of neurons, there's two different physical effects. So if there are two different physical effects from the experience of looking at a stop sign, then the thought experiment doesn't work. Necessarily for Jackson, you seeing the stop sign, Mary seeing the stop sign, has to have the exact same physical reaction in the brain. So that should sound a little bit familiar to you. And if it doesn't, it should be familiar right now. Here, subjective mental events have no physical effects whatsoever. What is the name of that thesis? Epiphenomenalism. So we talked about this when we were talking about physicalism initially, and how physicalism doesn't have this problem of interaction that dualism has. So dualism has this problem of interaction, that how does a non-physical entity cause anything physical, or how do physical entities cause anything in a non-physical entity? So how does this physical fire on my arm cause a non-physical mental state of pain? Problem of interaction. And epiphenomenalism was this story or theory that was attempting to explain how these bodily events can cause mental events. Epiphenomenalism is supposed to solve half the problem, because the epiphenomenalist says that mental events have no physical effects. They're dead ends, byproducts, side effects, without any further consequences in the brain. The brain directly causes the bodily movements. At the same time as these mental events are occurring, the mental events just simply have no effects. They don't do anything. They're just there. They're just the accidental byproducts of the process. And I use the example of thunder, lightning. So like the idea is like electrical discharge from the sky to the ground causes two things, thunder and lightning. Lightning comes first and then thunder. So light travels faster than sound. That's why that works. So most people think that thunder is caused by lightning, but it's not. The thunder is a completely separate physical process that has nothing to do with the lightning flash, except for they have this joint effect from a single prior cause. We mistakenly infer from the fact that the lightning always occurs before the thunder, that the lightning is therefore the cause of the thunder. But that's an error in our reasoning. And it wasn't until we learned more science that we learned that it was a mistake. So the epiphenomenalist is saying that we're making the same mistake about our mental events, our mental states. Because the mental effect happens before the physical movement of our body. So there's a fire under your arm, you have that mental effect of pain, and you have this physical moving of the arm. So we always have the pain and then the movement, right? There's always this like pattern. And so we mistakenly infer causation from that pattern. But the epiphenomenalist is going to say, just like with lightning and thunder, later on down the road, we're going to learn that this was all a mistake It's that pattern that we see all the time. We just attribute causation, but there's no actual causation there. So why would you be an epiphenomenalist? You might be a dualist trying to solve the problem of interaction, how these non-physical events can be caused by physical events or vice versa. You might also be an epiphenomenalist because of Jackson. Jackson is forced into epiphenomenalism. You have to buy that when Mary sees red, the physical effect in her brain, the same cluster of neurons, is identical to the physical effects in your brain or my brain when we see red. So even though she's seeing some grayscale and we're seeing actual red, we have to buy that they produce the same pattern, the same discharge in her neurons. So presumably when you see red, there's a cluster of neurons that fires. And then when you see yellow, there's a different cluster of neurons that fires. There's a difference in the kind of action potential signals that are sent from your visual cortex to, let's say, your foot. Like, why do I say your foot? So let's say you're driving and then you have this red experience. Maybe you see this red octagon. What are you going to do? You're going to push your foot down on the brakes. You're going to have this bodily movement to push your foot down on the brake. Now, let's say you're driving along and you see, you come to an intersection and you see a little yellow light. Maybe what's going to be the bodily reaction? Maybe you slam on the accelerator because you want to make it through that yellow light before it turns red. When Mary sees this, she thinks you're just making a discrimination between one shade of gray and another shade of gray. But presumably there's some difference in effect when you see red and when you see yellow. If the sensory experience of red and yellow give you different bodily movements, then it must be because there's some difference in the signals that they're sending to your body. If the signals that were sent by red experience and yellow experience were the exact same, would there be a difference in your bodily movements? No, right? So if you saw red and cluster of neurons A fires, and then you see yellow and cluster of neuron A fires, then your body wouldn't do anything different. The exact same cluster of neurons fired, same cause, same effect. For Mary, when she sees gray shade 1, some cluster of neuron fires, presumably the same cluster of neuron that when you see red fires. And then when she sees the yield sign, some other cluster of neuron fires, the same cluster of neuron fires that fires when you see the yield sign. But in order for Jackson's argument to work, the neurons that fire when you see red have to be the same neurons that fire when she sees grayscale 1. And the neurons that fire when you see yellow has to be the same neurons that fire when you see grayscale 2, or when Mary sees grayscale 2. This idea that if the same neurons fired when you saw red as when you see yellow, this is kind of an implication of the principle of sufficient reason. So when you do science, if you see two identical physical setups, you should expect that they have the exact same physical effects. If you get different physical effects, then it must be because there are two different physical setups, unless you're working with the quantum level. So the same should operate in the mind, in the brain. If you see a red sensation and it produces braking behavior, and you see a yellow sensation and it produces acceleration behavior, then it has to be because there's some difference in links of the causal chains from the subjective experience to the bodily behavior. If that's true, then that's something Mary can discover, because again, she knows everything that there is to know about the brain and what goes on in the brain when you have certain experiences. She can tell the difference between her grayscale subjective experiences and your red subjective experiences. She should be able to tell the difference by the same process with the same method. And how can she tell the difference? Because the difference in effect between the two experiences. If she can tell a difference and she finds that there is an effect in your brain that never occurs in her brain, then she can infer that there is some subjective experience that she's never had. But according to Jackson's story, she cannot do that. She can never figure out that there is such a thing as the subjective experience of red until she actually steps outside the room and looks at a stop sign. If she would be able to do that inside of the room, if there is some telltale smoking gun detectable physical effect of having a red qualitative experience versus grayscale 1 qualitative experience, then the thought experiment never gets off the ground. If the effects are different, then there's something Mary does not know. But the story says she knows everything, so there can't be any difference in effect. And what is that saying? Epiphenomenalism is true. So that's my point here, is that if you're like Jackson, you buy the thought experiment and you say that she sees something or she learns something new when she steps out of the room, then you're committed to epiphenomenalism. Unless you find some way to get out of that implication, but it doesn't seem likely. It seems like you just have to reject the thought experiment altogether. It becomes an empirical question at this point. You have to go and look at the science and say, okay, when every single person looks at the soft sign, does the exact same physical effect occur in all of our brains? And I think the science says no, that especially with color vision, when I see red and when you see a stop sign and I see a stop sign, we see different shades of red. And this is just kind of highlighting that difference in our physical makeup when we have these secondary qualitative experience. Qualitative experience, I don't even know if I mentioned this, but that's qualia, the qualitative experience. So that's where that technical term qualia comes from, is our qualitative experience of things, of our experience of secondary